In this exam question, a ball is thrown vertically upwards with a velocity v from the edge of a roof of a 40-meter tall building. The ball takes 1.53 seconds to reach its maximum height and ignore all effects of air resistance. Seeing as this is a problem with no air resistance, it means that only gravity will work in on this projectile. This projectile will then follow a path as follows. The initial velocity was given as v. The velocity at its maximum height would be 0, seeing as it is a turning point, and the time to reach its maximum point is 1.53 seconds. At this position across velocity v, it'll have a negative velocity v, and the time it would take to reach this point would be double the time it took to reach its maximum height. In 3.1, we are asked to define the term free fall for a total of 2 marks. In 3.2.1, we are asked to calculate the magnitude of the initial velocity v of the ball for a total of 3 marks. In 3.2.1, we are asked to calculate this velocity v. To solve this velocity, we will use this part of the projectile only, seeing as we have the final velocity up there, as well as the time it took to reach the highest point. We also know that gravitational acceleration is 9.8 meters per second squared downward. And in this problem, I'm going to take down as negative, which means that everything in the downward direction needs to be negative and everything in the upwards direction needs to be positive. Looking at the 4 equations of motion that we have on hand, we can see that we have enough information to use the first equation, which gives me an initial velocity for the ball of 14.99 meters per second in the upward direction. In this question, we were asked to calculate the magnitude, but you would never lose marks for indicating direction. 3.2.2 asks for the maximum height reached by the ball above the edge of the roof for a total of 3 marks. So in 3.2.2, they ask for this height, which the ball would reach above the building. If we look at our equations of motion, I can either make use of equation 2 or equation 3, seeing as both of them have the change in position, which we want to calculate. And we have enough information to use either one of them. Which gives us a displacement of 11.46 meters above the building. 3.3 says, take the edge of the roof as the reference point. Determine the position of the ball relative to the edge of the roof after 4 seconds for a total of 3 marks. In 3.3, they are asking us where would this ball be after 4 seconds. So it will be somewhere approximately over there, seeing as it would take 3.06 seconds to reach this point. So 4 seconds would be somewhere after there. So we need to calculate this position below the roof, seeing as this is our reference point, the roof. To solve this problem, we would use this entire projectile up till the 4-second mark. We have the initial velocity of 14.99, the time it takes to reach this point, but we do not have the final velocity at that point. So looking at our equations of motion, we need one of them containing the delta y. We don't have the final velocity, so we would not make use of equation 2. So let's have a look at equation 3. For equation 3, we have the initial velocity, the time of 4 seconds, as well as your acceleration. Which gives us a negative answer of 18.44 meters. So just remember that the negative is indicating direction. We took down to be negative, so this means it is downward from my reference point. So this is 18.44 meters. 3.4 says, will any of the answers to question 3.2 and 3.3 change if the height of the building is 30 meters? Say yes or no and give a reason for your answer. Now the answers that we calculated in 3.2 and 3.3 are independent of the height of the building. So even if this height is changed to 30 meters, it will not affect the height reached by the ball or any of the other questions.